Welcome to The Explainer. Today, we are diving headfirst into one of the weirdest, most profound ideas in all of science. Seriously, this is an idea that really messes with our whole understanding of reality itself.
So, let's just start with a really provocative question. What if two tiny particles, separated by billions of miles, could somehow act as a single object, instantly connected, as if all that space between them just didn't exist?
To even get our heads around this, we got to go back in time, back to the early 20th century. You see, physics was kind of having an identity crisis. It was completely split between two powerful but totally conflicting views of how the universe works.
So on one side, you had Einstein's theory of relativity. It described this grand, clockwork universe where space and time are woven together and all the laws are predictable. But on the other side, you had quantum mechanics. This was the science of the super-small, a bizarre world of pure chance and uncertainty, where reality itself doesn't even seem to be real until we actually look at it.
Now, Einstein, he absolutely hated this quantum stuff. He famously said he couldn't believe that God plays dice with the universe. The idea that reality was just a fuzzy cloud of probabilities until we measured it, he just couldn't get on board with that.
So in 1935, he gets together with two of his colleagues, Boris Podolsky and Nathan Rosen, and they write this paper. And their goal was pretty straightforward. They wanted to expose what they saw as a fatal flaw in quantum theory, to prove that it was an incomplete picture of the world.
And his whole argument was built on this core principle from his own work, something called locality. And really, it's just common sense, right? If you want to push me, you have to actually touch me. Something has to cross the space between us. A signal, a sound wave, whatever. And crucially, nothing can travel faster than the speed of light. That's the cosmic speed limit.
So Einstein sets this trap. He comes up with a thought experiment that he believes showed just how absurd quantum theory was. He pointed to the strange connection that the theory predicted, a link that seemed to break his unbreakable rule of locality. He even gave it a name. He mocked it, calling it spooky action at a distance.
But here's the ultimate irony. In a classic case of unintended consequences, Einstein's attempt to kill quantum theory actually ended up revealing its most mind-blowing prediction of all: quantum entanglement.
Yeah, the very thing he thought was ridiculous turned out to be a central part of the theory. It predicted something called non-locality. And what this means, basically, is that two entangled particles act like a single, unified system, no matter how much space you put between them. Think of it like this. Imagine you have two coins, and they're magically linked. If you flip one and it comes up heads, you know instantly that the other one is tails, even if that other coin is on the other side of the galaxy. It's not that a signal travels between them. It's like they're just two sides of the same coin, and the space between them means nothing to them. Now, you can't use this to send messages faster than light. You can't force your coin to be heads to send a message. The outcome is always random. But the connection, that connection is perfect, and it's instantaneous.
For decades, this whole spooky action thing was just a debate for philosophers. I mean, Einstein and his great rival Niels Bohr argued about it until they died, but there was just no way to know who was right. Was it a real thing, or was it just some weird quirk in the math?
And then technology finally caught up to the theory. In the 60s and 80s, physicists like John Clauser and Elaine Aspect designed these brilliant experiments that could actually test the idea. And what they found was decisive. This spooky, non-local connection was absolutely real. And in 2022, they, along with another pioneer, Anton Zeilinger, won the Nobel Prize for their work, for proving that on this one spooky point, the great Einstein was actually wrong.
You know, proving entanglement wasn't just the end of an argument. It was the beginning of a whole new chapter, one that took ideas straight out of science fiction, I'm talking teleportation, and turned them into actual scientific fact. It paved the way for things like quantum computers and totally uncrackable codes. And this was shown in this incredible experiment by the Nobel laureate Anton Zeilinger. So check this out. His team starts with two entangled photons, particles of light. They keep one in their lab on one of the Canary Islands, and they send the other one 143 kilometers away to a different island. Then they grab a third photon and entangle it with the one they kept in the lab. And here is where it gets just wild. The exact moment they did that, the unique quantum identity of that third photon was instantly stamped onto the distant one, 143 kilometers away. The information didn't fly through the air. It was like it just vanished from one spot and reappeared in the other. They had achieved quantum teleportation. Not of a person, of course, but of pure information. So all of this leaves us with this huge, profound paradox.
On the one hand, modern physics gives us relativity, which says space-time is the fundamental fabric of reality. It's everything. And on the other hand, it gives us quantum mechanics, which has a phenomenon that acts as if space-time isn't even there. And the craziest part? The experiments prove that they're both right.
So what you should really take away from this is a deep, deep question about the nature of reality itself. If the universe's most fundamental connections don't care about distance, what does that say about the space we walk through every day? If this spooky action doesn't care about time, what does that say about the clock on your wall? It suggests that maybe, just maybe, space and time aren't this fundamental stage we think they are. Maybe they're just an illusion, something that emerges from a much deeper and much, much stranger reality.